Hey everyone, and welcome back to the AI Research Roundup. I'm your host Alex, and today is May 4th, 2025. Alright, let's dive into our first topic. This ICLR conference paper titled Restructuring Vector Quantization with the Rotation Trick, published just a few months back on January 22nd. This paper tackles a tricky issue in VQ-VAEs, specifically how to handle gradients during the non-differentiable quantization step. They propose a novel rotation trick for better gradient propagation. Okay, so this figure really helps visualize the core idea. It shows how the encoder output, that's E, is rotated and rescaled to match its nearest codebook vector Q in the forward pass. But the key difference is in the backward pass. See how the standard saint just copies the gradient? Well, the rotation trick preserves the angle, meaning the gradient update for co-stano actually depends on where it was relative to Q. This helps utilize the codebook better. Building on that, this figure directly compares the standard saint approach with the rotation trick. Okay, you can see how, for different encoder outputs, E1 and E2 near the codebook vector Q, STE just copies the gradient QL direction onto them. But the rotation trick, well, it rotates the gradient, so the angle between the vector and its gradient stays the same, as shown by those little arcs. This preserves more information for updating the encoder. Okay, so this next figure really drives home the consequences of those different gradient approaches. It shows how the distance between the encoder output E and the codebook vector Q changes after an update, with saint. Well, the plot is flat, meaning the relative distance doesn't change much. But the rotation trick, it actively changes the distance. Depending on the angles, the update either pushes E away, that's the blue region, or pulls it closer towards Q, which is the green region. Okay, moving to the results. This table then details the performance for VQ-VAE on ImageNet. It compares the standard approach, Gumbel, VQ-VAE, and the rotation trick. Alright, look at the codebook usage. It jumps dramatically with the rotation trick, like from 15% to 86% in one setting. And the quantization error? It drops substantially. These quantitative improvements directly translate into better reconstruction metrics like RFID and RIS, showing the trick's practical advantage. Alright, and this next table looks at a different model, Timesformer VQ-VAE, on video datasets BAIR and UCF 101. While the standard approach really struggles, suffering from codebook collapse, usage is less than 1%, but applying the rotation trick, usage jumps dramatically to 43% and 30%. This translates directly to much better validation loss and especially RFVD scores, indicating significantly improved video quality compared to the baseline. And this figure really drives home the visual impact on the BAIR dataset. Okay, you can see the original video frames on the left, then the saint reconstructions in the middle. They're completely garbled, showing that codebook collapse in action, using just 4 codes. But compare that to the rotation trick reconstructions on the right. They're vastly clearer, much closer to the original, using hundreds of codes instead. Alright, wrapping up then, the key takeaway is that this rotation trick offers a much more effective gradient path than saint for VQ-VAEs. By preserving that angular information during backpropagation, it drastically improves codebook utilization, prevents collapse, and leads to substantially better reconstruction quality, as we saw in the results. That's all for this AI Research Roundup. Thanks for tuning in.